This is a OneWheel. These things are really fun to ride, but they have one problem. They have a wheel, and wheels are cringe. So, I built this. My version of the OneWheel uses tracks, so it should be able to conquer any terrain and can be used in pretty much any condition. Before I built this project, nothing similar existed. So in this video, I'm going to show you how I designed, built, and tested this thing all from scratch. And we'll see if this thing is actually more capable than the OneWheel itself. This design can really be broken down into three parts: the drive system, the structure, and the electronics. The most important part of this is the motor, since this is a vehicle after all.
I had this 1800 watt brushless motor laying around, and it should be perfect for this build.
The drive system is primarily 3D printed, including this giant drive gear. All of these parts need to be extremely durable, so I used some carbon fiber filled materials for extra strength. When building projects like this, planning out the steps for assembly is very important. But for this project, I did almost zero of that. And it really came back to bite me a couple times. I found out the hard way that this motor back housing has to be attached to the frame rail first, and then attached to the motor. Luckily, once the motor is attached, the drive gear can just slide right over it. But before this drive gear can get installed, I have to press into place the largest and most expensive bearing I've ever used. This thing is absolutely huge. It has an outer diameter of 150 millimeters, and it needs to be this big so it can slip over the motor.
Oh yeah. And then to connect the motor gear to this drive hub,
I've got a bunch of planet gears. This planet gear arrangement gives the motor a 4-to-1 reduction, which will help give this thing more torque. Holding all the gears in place is a custom plate on the front of the motor, which I machined on my CNC router. This plate was machined from thick 8mm aluminum, just to make sure the threads don't pull out from high forces.
that ain't going anywhere.
With this gearbox assembled, I wanted to make sure it operates as smoothly as possible. So I put a bunch of grease into it to help lubricate everything. To make sure no dirt or sand gets into this gearbox, which would destroy the plastic, I sealed it off with another custom machined aluminum plate. This one is made from 1/4-inch aluminum, and it also has 2 bearings mounted on it, which attach to the other frame rail. Since this is a new design, I found myself referring to the CAD assembly very often while building this. Luckily, this is really easy to do because I used Onshape, the sponsor of this video, which means I can just pull up the design on my phone. Onshape is an entirely cloud-native CAD platform, and I've been using it for a couple years now, and it's awesome. It has all the features needed to make complex designs like this, and it streamlines the whole process since there's no clunky files and everything is just stored in the cloud. It also has really robust version control, which I've used on a couple projects for testing out different ideas and making different versions of the same design. It allows you to fork things kind of like you do on GitHub, which is just a really clean way to do revision management. Onshape is also completely parametric, so you can go back in your design history and make changes as needed. This helps me out a ton because everything just kind of updates in your assembly and you don't have to go back and redo things. They also have some really cool stress analysis tools that I've used before, and an entire cam studio. Onshape is free to use, and honestly I can't recommend it enough. So check it out with the link in the description below and use it for your next project. Alright, so track systems like this need to have rollers, which support the part of the track that actually touches the ground. These can be seen on all sorts of vehicles, such as tanks and heavy equipment. On this vehicle, these are just 3D printed. However, I did add some cutouts to the rollers, which actually increase the strength since there's more perimeters. And then to make these rollers smoother to ride on, I printed some shells out of TPU. TPU is much more flexible than PLA, so hopefully this adds a little bit of cushion. I also added an outer profile to these parts to hopefully make this thing easier to turn when you're riding it. These rollers get assembled using some epoxy just to make sure everything stays in place while you're riding. Bearings get pressed into each end and then they slide over an 8mm shaft. There are 2 sets of rollers in this design, which are sandwiched between pieces of aluminum extrusion, making this a very strong and hopefully durable design. Side plates are used to connect the lower roller assembly to the upper drive assembly, and everything gets held together with just a couple bolts. These side plates are probably a little overkill, but I wanted to make sure this thing was as robust as possible since I know I'm going to crash on it. To actually make this thing move, I need electronics. On a OneWheel, the rider shifts his weight forward or backward to control which direction the OneWheel moves. Since this track system has a flat bottom, it makes it almost impossible to tilt the structure forward or backward. So instead, to control this thing, I'm using this hand remote. This hand remote talks to an electronic speed controller, which is called a VESC. This actually sends the signals to control the motor. And powering everything, I need at least 48 volts. So I put 2 6S batteries in series. Then of course, no build is complete without the lights. So I added a front and a rear light bar, which helps you tell the orientation and also just makes it look super cool. Lastly, I need somewhere to actually stand on this thing. I thought some nice wood panels would look good, so I threw some plywood on my CNC router and cut out the shapes I needed. And then to really bring the whole look together, I engraved a logo on the front panel, which turned out awesome. And then I threw some stain on the whole thing, and these things look incredible. While I was getting these electronics to work, I did a little bit of tuning, and part of that was I took it outside and tried to ride it. I was actually really impressed by how well this thing worked. It's definitely tricky to ride, but eventually I kind of got the hang of it. We still had a lot of snow on the ground when I was testing this out, and seeing this thing just plow through the snow was awesome. However, while I was riding it, I heard some cracking noises, and realized that when I tried to turn, the profile of the rollers on the bottom was actually putting a ton of stress onto the treads and causing them to crack. This became very apparent when all of a sudden the tracks just completely tore apart and it just stopped moving. So clearly some upgrades are needed already. Luckily, this is a really easy fix. I changed out the rollers to a flat profile, and then I added the rounded profile to the tracks themselves. So this should allow us to turn a little bit easier. Hopefully now we can give this thing a real test.
All right, moment of truth. Let's see if this thing actually works. Using the remote, it goes forwards and backwards. But can I actually ride it? It's definitely not gonna be easy. Even getting on this thing is hard. All right, here we go. Oh. Whew. Definitely not easy. Oh. Let's try going in this direction. Whoa.
Now, it was super muddy while I was testing this, but this thing had zero issues with traction. However, I found that even when I was leaning, I had a really hard time steering this thing.
All right, turning this thing is definitely not easy. Try it again. Oh. Maybe this was not such a good idea.
Now, I did not give up here. I kept on trying to ride this, and I must have fallen off this thing 100 different times. And it's not the one track that has the problem. This thing absolutely rips, especially when there's no weight on it. But I just can't keep my balance on here. It's really difficult. To make this easier on myself, I took this thing to an empty parking lot where I could practice. This flat ground definitely helped out a lot. And finally, I was starting to see some success riding this thing. Even though these were the best possible riding conditions, this thing is still insanely hard to ride, and I still took a couple spills.
All right, let's be honest. This thing is not working very well. The fact that this thing is controlled with a hand remote makes it very hard to maintain your balance. Also, leaning doesn't actually have any effect on steering. You're basically just stuck going straight. And ironically, this thing works the best when no one is riding it. It can go pretty much anywhere. Now, in an open space like a parking lot, this thing is pretty straightforward to ride. It's easy to maintain your balance and you can just drive straight. But that's really not what this thing was meant for. It's meant for off-road. That's why it has tracks. With the right design changes, I think this idea could work. I've already got a couple ideas in mind, but I'm curious what you guys think, so let me know down in the comments what you think I should add or change. But for this version 1 design, it looks really cool, but it just doesn't work very well. Not every project needs to be a huge success, and this thing is still cheaper than the OneWheel. Regardless, thanks so much for watching. If you like projects like this, subscribe for more, and I'll see you guys in the next one.